Welcome to 5-Minute Math. This is Carrie Rhinehart. Today I'm going to be looking at scientific notation. If you're following along in the book, this is from Algebra 1, Unit 5, Lesson 2. So scientific notation is just a way to write numbers, very large numbers or very small numbers, in a more concise, easy to read or easy to write way. Now, when you write in scientific notation, the first number, for example, let's 5.83 times 10 to the fifth. That's an example of scientific notation. This first number is like our coefficient, and it must be between 1 and 10. It's got to be between 1 and 10 or it won't be considered scientific notation. And then the second part is always 10 to some power. Okay. Now, if that power is a positive number, that means the actual value that this represents is a very large number, or it's larger than the 5.83. And if that exponent is negative, that means you're dealing with a small number. Let's look at an example. Let's say that we're given the number 106,700,000, and we are asked to write this in scientific notation. We need to write it so that the first number is between 1 and 10. Okay? And to do this, that means we need to take the decimal, which currently the decimal is right here. But we need to move it as far to the left as possible so that it's between the first two digits on the left, not including 0. So that would be, now I know it's between a 1 and a 0 here, but you need to move it until the 0 is not on the left. So we need to move the decimal from here, 1, 2, 3, 4, 5, 6, 7, 8 spaces to the left, so that now we have 1.067. Now I could put all those zeros, but you don't need to here since it's a decimal, times 10 to the, well, we moved that decimal 8 places. And since the original value is 106 million, it's a very large number, that 8 should be positive. So this would be your answer in scientific notation. Now let's go the other way. Let's say that we have the number 5.67 times 10 to the negative 7th. And we need to convert this back to the actual value that it represents. Well, since 10 is raised to a negative power, we know that the number we're dealing with is a small number. We need to take the decimal right here and make this smaller. In order to make it smaller, we would move to the left 7 places. Let's see, 1, 2, 3, 4, 5, 6, one more place. And for all of these spaces that you moved over, you would plug a 0 in here. So you can have a 0 in all these spots, so you're going to get 1, 2, 3, 4, 5, 6 zeros, 5, 6, 7, and then you're done. So 5.67 times 10 to the negative 7th is equivalent to this value right here. So again, if your exponent is negative in scientific notation, that means the actual value is very small. If your exponent is positive, that means the actual value is large. You also need to know how to multiply and divide when you have numbers in scientific notation. Let's look at an example of that. So let's say we have 5.23 times 10 squared, or 10 to the second, times 1.41 times 10 to the negative 8. Now, remember I said these numbers are like your coefficients. So just like with exponent rules, coefficients get multiplied. So we're going to multiply 5.23 times 1.41, which gives me 7.3743 times, now with these, just like with exponent rules, you keep your base, so 10 is the base, and you add your exponent. So 2 plus negative 8 is negative 6. All right, and then when you're dividing, it's almost the same as multiplying, but make sure to divide your coefficients and subtract your exponents, just like you would with regular exponent rules.